So, you would have had a wonderful overview of Indian mathematics with Professor Srinivas. So, in this talk basically I will be covering mathematics in Vedas and Sulbasutras. So, this will be done in two parts. Vedas, as all of you know, is the most ancient scripture that is available to us today, and the Sulbasutras form a part of what are known as Kalpasutras, which itself is a part of Vedanga. So, what we will be covering is basically the mathematical references that can be found in Vedas and the geometry, arithmetic, algebra, etc. So, which can be found in the class of texts called Sulbasutras. The purpose of Vedas is obviously not to deal with mathematics. So, it has to do something with the relation of human and nature and the propitiation of nature in the form of a divine being through humans, etc. So, this is primarily the content of Vedas, and in fact it has been succinctly stated in one of the most ancient texts called Vedanga Jyotisha, wherein the purpose of Veda has been very clearly defined as Vedahi yajñartham abhipravrittaha. So, yajñartham abhipravrittaha is primarily propitiation of the divinity. So, but you might have also heard perhaps in the overview by Professor Srinivas, wherein Mahaviracharya, so while defining the scope of mathematics, he says Laukike Vaidike chapi tatha samayike piyaha vyaparas tatra sarvatra sankhyanam upayujyate. So, you will see mathematics in every aspect of life, whether it is worldly, whether it is Vedic, whether it is religious, and so on. So, anyway, so what we will be trying to do is trace out some references which can be found in Vedas and then see what one can derive from those references with regard to the knowledge of mathematics which was available in those ancient periods. So, this is primarily the idea of touching upon the most ancient scripture, so Vedic scripture, and then we will move on to Sulbasutras. So, in this lecture we will start with references in Vedas and then move on to discuss what are the Sulbasutra texts. So, what do they deal with, and what does the term Sulbasutra mean, and one of the most important things. So, as I was mentioning, Vedahi yajñartham abhipravrittaha, when you have to perform sacrifices, you have to create necessary platform, so fire altars and so on. So, and the construction, so that is involved in creating such platforms, etc., is the primary content of the text called Sulbasutras. So, the most important thing is to find out the cardinal directions. So, that is one of the most interesting experiments which can be done with a very simple device called Shanku. I will be discussing that, and this is a prerequisite for starting yajna. So, for doing yajna you have to create a certain yajna shala, and yajna shala cannot be constructed without knowing the exact directions. So, that is what we mean. Cardinal directions primarily mean east, west, north, south. So, one may naively think that after all, by looking at sunrise I will be able to determine the direction, but that is not the case, because of Uttarayana and Dakshinayana, sun has northerly and southerly motion. So, we need to conduct a very simple experiment, but this experiment is one of the most foolproof experiments. So, we will be discussing all that. So, then we will also deal with the construction of certain geometrical objects. So, square, circle. See, when I say Bodhayana's method of construction of square, so this may look pretty simple. So, after all, so if I need to construct a square, I need to draw a line, and then I can have a set square, I can have a t square, and then I can draw this. I mean, what is the great deal about it? So, that is not the thing. They did not have t square or set square, but then Bodhayana has discussed a very interesting method by which all that you need is a couple of nails and then a rope. So, with that you will be able to construct a perfect square. So, that is what we will be discussing there, and then we will be moving on to what is today called Pythagorean Theorem or Pythagoras Theorem. So, we call it Sulbasutra or Sulba Theorem, and there are different versions of it, Bodhayana version, Manava version. So, we will be discussing that, and then we will also see how the triplets have been listed in these ancient texts, and then application of Sulbasutra. So, all that will be discussed in this lecture. Before proceeding further, so we will try to look into these Upanishad, so which is a part of the Veda. So, there are primarily 10 principal Upanishads and one of them is Mundaka Upanishad. So, where does this mathematics fall within this Vedic corpus of knowledge? So, here we have a passage in Mundaka Upanishad, so which tries to classify the body of knowledge itself into two groups, one is called Para, the other is called Apara. Para deals with most fundamental questions, so who am I, so what is the purpose of my existence, what is my connection with this, all that. So, this is the domain of Para, and Apara, so all the other things are put under Apara. In fact, even the Vedas, so the Karma Kanda section of Vedas falls under Apara Vidya. So, we have the 4 Vedas as it is listed, so Rig Veda, Yajurveda, Samaveda, Atharva Veda. Then we have the 6 Vedanga, Siksha, Kalpa, Vyakarana, Nirukta, Chanda, Jyotisha. It is under this Jyotisham the mathematics also is clubbed into. So, Ganitam is not listed, but the development of mathematics, as you might have seen, so is primarily in trying to solve problems in astronomy, and in fact as we will see later, so the connections between the mathematical development and the application in astronomy will become quite evident when we look into the later part of the course as to why they had to solve first order intermediate equation and so on in the later part of the course. So, this is how one is able to relate mathematics with the most ancient scripture. So, this Jyotisham includes Ganitam too. So, coming to Vedas as such, I was mentioning that we find some references here and there, and references will be only in the form of primarily numbers. So, Sankhyanam Upayujyate. So, when he said, so Sankhyanam is primarily science of calculation, calculating the number of days, calculating on which day what has to be performed and how many number of days in which the sacrifice has to be done. So, there are various other things and how periodically they have to be done, and the numbers which we find in the Vedic literature are mostly related to the propitiation which is done towards a certain particular deity. For instance, this mantra which you can see here, Shataya Swaha, Sahasraya Swaha, Ayutaya Swaha, Niyutaya Swaha. So, this basically lists all the powers of tens starting from 10 to the power of 2 to 10 to the power of 12. So, Shata refers to 10 to the power of 2, and towards the end of this passage you find Parardhaya Swaha. So, Parardha refers to 10 to the power of 12. The list of all the words which refer to the power of 10 has been listed in this. Similarly, in the next one, so we find Ekachame, Tisrachame, Panchachame. So, we find all the odd numbers listed here, and Chatasrachame, Ashtauchame and so on, the power multiples of 4. So, these things are listed. Further, there is an interesting passage in Rig Veda. So, here in the passage Vimshati, Trimshati, Chatvarimshat, Panchashat, Shashti, so all the multiples of 10. So, I am just quoting this in order to convey a certain message that these people have been quite conversant with the decimal place value system. So, in fact, this is one of the most fundamental discoveries. So, we will deal with that exclusively in a lecture later, but then you can see that, so all the numbers which have been mentioned, for instance, look at this mantra, Trini Shata, Tri Sahasran, Yagnim, Trimshascha, Devanava, Chasaparyan. So, this mantra, Trini Shata, Tri Sahasrani, Trimshascha, Devaha. So, Nava refers to 9 and the rest 3339. So, this is a very interesting number. So, if you look at, so this is basically sum of 33, 303, 373, and you get this particular sum, and this number is also very close to a period of 18 years. There have been articles written wherein they try to trace the origin of this number and what is so special about this number. What is interesting here is to note that there is unambiguous evidence, so by which we will be able to see that the Vedic priests have been very conversant with the decimal place value system. And we also have this mantra Purnamadav Purnamidam Purnat as a Shanti mantra of Ishavasya Upanishad. So, this Shanti mantra speaks of the notion of infinity, Purnasya Purnamadaya Purnameva Avashishyate. So, you take Purna from Purna and what remains is also Purna. So, this is very close to the notion of infinity. Now, I move on to the Sulbasutra texts. So, as I was mentioning earlier, the Sulbasutra texts form a part of what are known as Kalpa Sutras. In fact, Kalpa Sutra includes Shrauta Sutra, Grihya Sutra, Dharma Sutra and Shulva Sutra. So, Shrauta Sutras are aphorisms which have to do with certain rituals which are done for the societal welfare. So, Shrauta Sutras, Yagas, etc. So, and Grihya Sutras, so has to do with the rituals which are performed in the household. So, certain texts which will guide the performance of these things, so are referred to by these names. So, Grihya Sutras. Then we have Dharma Sutras. So, Dharma Sutras have to do with the general code of conduct which has to be followed for the well-being of society. So, that is what is referred to, and the duties which have to be done by different class of people and so on. So, this is the subject matter of Dharma Sutra. And when we come to Shulva Sutras, Shulva Sutras are texts which have been primarily composed to assist the Shulvakaras in the construction of various sacrificial altars. The first sutra in some of this Shulva Sutras is Atheme Agni Chayaha. Agni Chayaha, Chaya is basically a collection of bricks, etc. So, Chayanam is putting together. So, putting together to create a certain platform on which these rituals can be performed. So, what does the term Shulba mean? So, in fact, Shulva Sutra is a compound word. Shulba is one part and Sutra is another part. Sutra is a type of writing. In fact, this has been the most ancient form of composing texts. So, if you look at the Sanskrit literature that is available to us, the most ancient ones have been in the form of sutras. So, we have this Brahma Sutra of Badarayana, we have Jaimini Sutras, we have Panini Sutras, so Ashtadhyayi, so we have Patanjali's Yoga Sutras. So, all of them have been composed in the form of what is referred to as sutra style. Of course, there are definitions for sutras. So, this Shulva Sutras is a compound word wherein this Shulba has a meaning of measuring, Shulba Mane. So, in fact, in Sanskrit, so most of the words are derived from the roots and the root is Shulba, Shulba Mane. So, Mana is measuring. So, Shulba Mane, in fact, this word can be derived by different ways. In fact, what is called Bhava Vyutpatti, Karma Vyutpatti, Karana Vyutpatti and so on. So, Bhava Vyutpatti, if you do this, so Shulbanam Shulbaha. So, this is how the word can be derived and it refers to the act of measuring. Shulbyate iti Shulbaha, when you say you measure something and that entity is the object of measurement, and that is the Karma Vyutpatti. And Karana Vyutpatti, when you say, so Karana is an instrument, so by which you make measurement. So, all of them are applicable when we refer to the content of the Shulva Sutra text. So, and therefore, this compound Shulva Sutra actually means a text which discusses the act of measuring. So, obviously, the entity which is measured, the instrument which is used for measurement, so all of them will be referred to into this Shulva Sutra text. So, the sutra itself is a very tightly composed text. So, you will not find unnecessary words into the sutras. So, that is the very definition of sutra, Alpaksharam Asandigdham Saravad Vishwato Mukham and so on. And the Shulva Sutras obviously cannot be understood on their own. So, without either the teacher or teacher plus commentator. So, if teacher is not available, we resort to commentaries which have been composed at a much later period on the Shulva Sutras for understanding what does this sutra convey. There are 7 Shulva Sutras, so which are available for us today. These are the texts Bodhayana, Apastamba, Katyayana, Manava, Maitrayana, Varaha and Vadhula. So, of them 4 are more popular and more studies have gone into the first 4 and the later that have not been studied that much, but anyway. So according to scholars, so Bodhayana Sulbasutra seems to be the most earliest of the Sulbasutras which are available to us today. So this is based on certain analysis which have been done in the with reference to the style, with reference to completeness, with reference to the archaic usage which is found in those texts. So based on this they have felt that Bodhayana must be the most earliest Sulbasutra, and one also finds certain sutras almost similar in later, for instance in Katyayana Sulbasutra. So we will find the same sutra repeated with minor changes. So and it is more extensive also, this Bodhayana Sulbasutra, and therefore they feel that it is the most ancient one. Bodhayana Sulbasutra is made up of 3 chapters consisting of 520 sutras, and the composition is something like this. So they have commentaries as I was mentioning. So for Bodhayana we have 2 commentaries, one by Dwarkanatha, the other by Venkateshwara Dikshita. For Apastamba we have 4 commentaries which are identified by Kapardhi Swamin, Karavinda Swamin, Sundar Raja, Gopala, and this Katyayana Sulbasutra. So we have one very interesting commentary by Rama or Ramachandra. So this Rama seems to have improved upon certain algorithms which have been stated in Katyayana Sulbasutra, which I will be touching upon in my next lecture. So we have also a very interesting commentary by Mahidhara of this Katyayana Sulbasutra, wherein he has quoted several verses from various other things. This is also another interesting commentary. Now I will recite a couple of verses, so which is found in the commentary of Mahidhara. So wherein he defines what are the qualities that are expected of a Shulvakara. By Shulvakara I mean the one who assists, so the Vedic priest in the construction of the Yajnashala, okay, so where sacrifice is performed. So he says Sankhyaඥah, Parimanajñah, Samasutra Niranchakaha, so and so on. So Sankhyaඥah means the one who is versed in arithmetic, science of calculation, and Parimanajñah, so one who is versed with mensuration, and Pariprachakaha, he should be a sort of inquirer, and we also have the adjective Parashastra Kutuhalaha. See, Kutuhala means a certain enthusiasm in learning other disciplines also. See, today we have ended up into a certain situation wherein, so within civil engineering there will be some 20 disciplines, so he will know only to do this, he will know only to do this, so on and so on. So in the name of getting deep into something, so the overall understanding is all gone. Anyway, so here he describes the one who should be enthusiastic to know more and more things, and so the point I want to drive through these verses is that primarily, so he is not a person who should be considered as a merely geometer who will do only that kind of a thing, okay. So this is what it is, and there are various topics which are discussed in Sulbasutras. To give you an idea as to what would be the content of a Sulbasutra text, I have listed a few of them. For instance, you have Rekha Mana Paribhasha. See, Mana is measuring, Rekha Mana is measuring the length of a chord. So which means Paribhasha is a certain technical term. So they will define those technical terms. For instance, various units of measurements are used. So what are the units of measurements? Linear measurement. Then Chaturashra Karanopayaha. So Chaturashra, Ashra means a side, Chaturashra means 4-sided figure. So construction of 4-sided figure, square, rectangle, and so on. Then Karanyanayanam. So Karani here refers to square root, okay. So Karani, in fact Karani has various connotations, I will discuss that maybe a little later. So the Karanyanayanam means how do we find the square root of a non-square number, okay. So these things are discussed there. Then Kshetrakara Parinamaha. So Parinama is a transformation. So if you have a geometrical object of a particular shape, you would like to transform this object into some other object, and this is a area preserving transformation. So a square of a certain area should be transformed into a circle of the same area, then obviously you need to know the value of pi, so in some sense. So all that, so some approximations for that, and how do you do geometrically. So these are all discussed in these texts. They are very interesting things. and Nanavidha Vedi Viharanam. So, Vedi, as I told you, is a sort of sacrificial ground, Yajñashala. So, for different sacrifices you should construct the altar in different sizes and shapes, and see, in fact there are certain altars which have to be constructed in the form of bird, a falcon. So, but there is a certain constraint which is imposed, so you should have only 120 square meters. So, I am just saying in some units, so 120 square meters, 100 square meters, you should construct an altar in the form of a bird. So, which means a lot of calculation has to go into as to what kind of bricks you have to design, and it has to be of certain height also. So, different layers have to be arranged in a particular way, so that the structural stability is also taken care. So, you have to just pile the bricks. So, all that are discussed here, and they also discuss about the kind of material which has to go into preparation of this. This is another interesting aspect which one finds in Sulbasutras regarding the construction material and the process, so which has to be done to see that the bricks that you create are solid enough, and so on and so forth. Then how to manufacture bricks. So, these are all the contents of a typical Sulbasutra text. So, not every text will discuss every aspect of it. Okay. The topics that we would discuss here is roughly, so I will start with the determination of cardinal direction. So, this is called Diganayanam. So, Dik is direction, Anayanam is finding. So, that I will do as the first thing. Then how to construct perpendicular bisectors. Suppose you have determined east west line, then you have to construct a perpendicular bisector to get the what are the methods which are employed. Then construction of figures like square, trapezia, circles. So, these are all very interesting things, as I told you. So they are just done with nail and a rope. So, enunciation of certain geometrical principles, for instance the Sulbasutra, Sulba theorem. Okay. Sulbasutra is the ancient text which has the Pythagorean theorem, so in the most general form, not only triplets. So, these principles, and how do we make use of these principles? See, this Pythagorean theorem, which is called Bhuja Koti Karna Nyaya in Sanskrit. So, this theorem is so fundamental that it plays a major role in trying to even transform a particular geometrical object into some other shape, and so on, as we will see little later. Then construction of chitis. So, these are the various topics that we will discuss. Okay. So, determining the east west line. As you can see in the diagram, so here OX refers to the Shanku, a small stick which is well shaped, and there is a tip at the corner. Okay. So, it is sharpened at the top end, which is OX. So, then you draw a circle around this, and this sutra, so basically tells you that you have to create a certain horizontal plane. So, that is what is referred to by the word sama. Sama means a horizontal plane. So, same shankum nikhaya, nikhaya means sort of fixing, same in a horizontal plane, shanku is the stick. Okay. So, this is the device. So, nikhaya is having placed it well. Then he says shanku sammitataya rajva. So, rajju is rope, okay, the cord, so with which you will draw circle and all that, you will do all measurements. Shanku sammitataya rajva means, so you have to choose a rope of appropriate dimension which can be measured with the shanku. So, which means the rope has to be at least twice the shanku, then only you can measure with that. So, it is in that sense, and that has a certain astronomical significance which we will not discuss now. So, if the circle that you draw is too small, then while doing the shadow measurement, so the shadow need not even enter the circle here. So, what we will do is, so you create a platform, you place the stick, and then you see the shadow. So, the shadow, so the length keeps on decreasing, and at a certain point it will enter into the circle, and then in the afternoon it will move out of the circle. So, these 2 points have to be primarily marked, and they are A and B in this figure. Points A and B, so primarily define the east, west and the east points. Okay. So, once you draw a line, So, AB. So, A is marked in the forenoon as the shadow enters into the circle, and B is marked as the shadow exits from the circle. So, this experiment can be performed anywhere. So, only thing that you have to ensure is a flat surface. In fact, my friend Professor Srinivas, so once he was mentioning that his friend so consulted somebody regarding Vastu. So, then that person came up and then said, your house is not properly oriented in the east west direction. He was narrating to me once. So, this fellow said, oh, what do I do, and so on. So, then apparently he asked, how did that person who came for surveying tell you that your house is not properly oriented? Apparently he said he brought a small device wherein a magnetic needle was there, and then so he said that, so this is not properly oriented. So, this magnetic needle, so how precise it is? I mean, any device can deflect the magnetic, so your own card perhaps so can deflect the magnetic needle, and that will not give you the exact east west direction. So, in fact, the sort of foolproof method is this method. Today is a technotronic age wherein there are so many devices, and this itself, the precision is not something so which is so reliable. So, this is a very simple technique by which we will be able to see, and later when they saw that this is exactly oriented. Anyway, the point I am trying to convey here is this is a very, very simple experiment and a foolproof experiment which can be done at any place on any given day. So, which will give you the exact east west direction. Okay. So, this is a slide so which has been prepared based on a certain verse which is given in an astronomical work called Tantra Sangraha. So, which myself and Professor Sriram were studying at some point of time. So, this is a very interesting formula which is given here. So, if you look at this the formula, it is a sort of complicated, fairly complex formula which involves so a lot of trigonometric functions and the inverse of trigonometric function. In the left hand side what you find is t. So, t basically refers to the time, and in the right hand side what you find is phi and delta. So, phi refers to the latitude of the place and delta the declination of the sun. So, what I am trying to say here is, so with this simple device Shanku you will be able to precisely tell what the time is, provided you are able to see the where the sun is, the zenith distance of the sun, which is Z here. Once it is known, you will be able to get the time. So, this device is a very, very profound device. So, once the latitude itself can be of course found using this Shanku at any given place. What is the latitude of the place? A simple experiment will tell you. So, this formula is primarily conveyed so to give you a certain idea as to how even profound things can be done with this very simple device, and this also tells you the kind of sophistication that has gone into. So, as I was mentioning, so one of the commentators very clearly explains as to why you need to conduct this experiment to determine east west. So, this Mahidhara says, see, Udayasthananam bahutvat pratidinam bhinnatvat aniyamena prachi jnatum na shakya. See, Udayasthana is the rising point. So, if you look at the eastern part of the horizon, so the rising point of the sun keeps on shifting. Bahutvat means it is many. Pratidinam bhinnatvat, in fact it varies by a very, very small amount every day, and prachi, east, cannot be known by simply looking at the eastern part of the horizon. So, finally he concludes, tataha arkat prachi jnanam durghatam. So, it is difficult to simply determine by looking at the sun. So, therefore, you need to conduct this experiment. So, having done this experiment, so you have to find out the perpendicular direction, that is the next problem. So, this is actually done in a couple of ways. One is Rajvabhyasanam, which is folding of the cord. See, you have drawn a line now, you have determined the east west, now you have to draw a perpendicular. So, all that you have is nails and rope. Today what we do is primarily this later method, Matsya Chitranam, which they call as by drawing fish figure. So, I will show this one by one. See, the first by cord folding is as simple as that. Suppose you have determined point A and B, all that they say is you have to take a rope which is twice AB, and then you have to mark the center of this. See, by folding it you will be able to mark the center of this rope. So once you do that, all that you need to do is you have to pull. So tie at the ends and then pull it on both these sides. So one side it will give you north, other side will give you south. So this will give you this perpendicular to the east west line. So this is the first method. The other method is, which is followed by even if you ask any school student, all that he will do is he will take a compass and then so he will draw a semicircle and then put it on the other side, draw the other circle. So this creates a figure, see, so a figure like this. So this looks like a fish and therefore it is called Matsya Chitranam. Matsya means fish. So by drawing fish figure you will be able to get the perpendicular direction. Now I come to a very interesting construction which has been discussed in Bodhayana Sulbasutra for constructing a square. See, Chaturashram Chikirshan, Chaturashra is square, Chikirshan desirous of doing. So he says Yavat Chikirshet. So whatever be the dimension, the side of the square, okay. So he says you take a rope of that length, okay. Tavatim Rajjum. So he says Ubhayataha Pasham Krutva. So in this figure, so P and Q refers to the tip of the rope and PQ basically gives you the side of the square. So what is to be done is, so you mark the midpoint of it and you have to fix it, fix a nail, then draw a circle. Is it clear? So you just in the next figure, so O is the nail and you draw a circle. So having done this, say all that we employ is couple of nails and then rope, that is all in trying to draw a square. So he says Madhye Shankum Nihanyat, means you Madhye O at the center fix the nail. Tasmin Pasho Pratimuncha Lakshanena Mandalam Parilikhet, draw a circle. Then Vishkambhantayoho, the term Vishkambha which you will encounter refers to the diameter of the circle. Vistara, Vishkambha etc. refer to the diameter. PQ is the diameter here. Vishkambhantayoho anta Shanku Nihanyat. See, you place a nail at P, you place a nail at Q. Then he says Purvasmin Pasham Pratimuchya. See, Pratimuchya, so is basically Dhrutva, tying. So it is a very special usage. In fact, this is one of the words which one can find in the ancient literature. So Muchya is normally same sort of removing, but Prati is a word when this adjective goes, it is tying, okay, Pratimuchya, tying, latching. So then he says you tie it and then the same string is used and you have to draw a circle, okay. Similarly, you tie it and then draw another circle, okay. So Pashena Mandalam Parilikhet Evam Aparasmin. So these two red circles are drawn. Te Yatra Sameyatam. See, wherever these two circles intersect, so which is E and F. See, so these are 2 points. With them you draw a line. So then you have to mark points R and S, okay. So Tena Dvitiyam Vishkambhama Yachet, the points R and S are drawn. Vishkambhantayoho Shanku Nihanyat. Again, see, we fixed a nail here, we fixed a nail here. Then he says you fix 2 more nails here and then that is all, you have got the square. How do you do? So then starting from P you have to draw a circle, see, as it was done, then you draw a circle, then you draw a circle, then you draw a circle. This is all he says. Evam Dakshinena, Evam Paschat, Evam Uttarataha. So once these 4 circles are drawn, so these dotted circles, all that has to be done is wherever these 2 circles intersect, you have to mark the point and you will get the square ABCD. It is a very beautiful construction which has been discussed in Bodhayana Sulbasutra to draw a square, whatever be the dimension, okay. It can be as long as you want, as big as you want. Then we have this so called Pythagorean theorem, so discussed here, and it is a explicit statement. Dirgha Chaturashrasya Akshnaya Rajjuhu Parshvamani Tiryangmani cha Yet Prithak Bhute Kurutaha Tadubhayam Karoti. This is the statement of Pythagorean theorem, okay. So Dirgha Chaturashra, Chaturashra as I said refers to a 4-sided figure, okay. Chaturashra, Ashra is side. Dirgha Chaturashra means elongated, elongated basically refers to a rectangle. Dirgha Chaturashrasya. Rajju is rope or line. Akshnaya Rajju, the word Akshnaya is not to be found in the classical literature, it can be found in the Vedic literature, and in fact there are various instances in which the word Akshnaya has been used. So this has been defined by the commentators of the Shulvakara also. In fact, Akshnaya, in fact today I incidentally saw in Chandogya Upanishad the word Akshnaya has been used, and Shankara in his commentary very beautifully defines it. Akshnaya Kona Chhidrataha Antara. So this is all he says. So Kona, if you want to say, see, for instance, if you draw a rectangle, so this is a Kona, corner. Kona Chhidrataha Antara means this particular thing is what is referred to as Akshnaya. So Akshnaya Rajjuhu refers to this. So this is a Dirgha Chaturashra. Dirgha Chaturashra Akshnaya Rajjuhu. So Parshvamani, so this can be taken as Parshvamani and this can be taken as Tiryangmani. So all that is said here is, if you think of drawing a square here and then drawing another square here, if you draw a square, so this will give you the area of these two. So Parshvamani Tiryangmani cha yat prithak bhute kurutaha tadubhayam karoti. This is something which is very well known. Tadubhayam karoti. So whatever be the area that is created by the two sides, so the hypotenuse also gives that. So this is basically the Pythagorean theorem. In fact, in yet another version, as I was mentioning earlier, the Katyayana version is primarily the Bodhayana Sutra as it is, with the only thing added iti kshetra jnanam. Iti kshetra jnanam can be understood in two different ways. So I would say that this is the most fundamental theorem which is to be known in this planar geometry, which cannot be dispensed with, and in fact the applications are many fold. So even in very complex calculations like the period of eclipse, etc. So all that we use is primarily this, a sort of right angle triangle. And so yet, see, in fact the commentators yet phalakam samachaturashra dvayam kurutaha. See, this is a very clear explanation. Yet phalakam, the word phala refers to area. So if you consider one side, whatever be the area created by that side, whatever be the area created, so that particular thing creates that area. So Kona Sutra Bhuta Rajjuhu Karoti. So this is what is the meaning of this sutra. Okay. This Manava Shulva Sutra also states this theorem, but in a slightly different form. So it says Ayamam Ayamagunam Vistaram Vistarenatu Samasya Vargamulam Yat Tat Karnam Tadvido Viduhu. This is a very clear statement. So Ayama and Vistara, they refer to the length and the breadth of this rectangle. So Ayamam Ayamagunam. So you multiply Ayama by Ama, Vistara by Vistara. So which means, so if you consider one side as A, find A square, then Vistara find B square. Samasya, Samasya means adding them together. See, Vargamulam is square root of that, square root of A square plus B square is C square, that kind of a thing. And Vargamulam is square root, so that gives you, so this is what essentially it is, Ayama square plus Vistara square, square root is Karna. So this is what it says. So soon after giving the theorem, so Dirgha Chaturashrasya Akshnaya Rajjuhu, so Bodhayana in the very next sutra gives several triplets. So here is the sutra, Tasam Trika Chatushkayo, Trika is 3, Chatushka is 4, so one triplet is 3, 4, 5, okay. Then Dwadashika Panchikayoho, Dwadasha is 12, Panchika is 5, then Panchadashika Ashtikayoho, 15, 8, so 17 square, then Saptika Chaturvimshatikayoho, 7 and 24, so is 25 square, Dwadashika Panchatrimshikayoho, so 12, 35 is 37, Panchadashika Shatrimshikayoho, so all that he says, Ityetasu Upalabdhihi, Ityetasu and so on. So you can go on constructing such triplets. So he gives a few triplets as examples of the theorem which he stated in the most general form in the previous sutra. Ashwarayana Sutra so gives a couple of other triplets. So, I am just listing them, and one could ask the question as to why he chose only these triplets. There are so many triplets which can be constructed. So, one can think of perhaps that the Sulvakaras thought of a certain general formula, and plugging in certain values you will be able to get those triplets. So, that is what I will show you in the next couple of minutes. For instance, if we look at one of the relations which has been given in Katyayana Sulbasutra. So, this is a algebraic relation. See, n a square so can be written in this particular form. Is it fine? So, Katyayana Sulbasutra so does not present it in this particular form, but in a certain context. So, in finding the value of root n you find a certain description which can be written in this particular form. Okay. Datta, so Bhutibhushan Datta, and in fact he was one of the pioneers in initiating the study of Indian mathematics, the contributions of Indians. So, he is a very great scholar. He has written a text called the Science of Shulbas. So, wherein I mean he has tried to analyze as to what would be the rationale in trying to present these examples soon after this theorem was stated. So, this if we make a substitution, n is equal to m square and we plug in a is equal to 1. So, then this transforms into this particular form. So, if we plug in the value m is equal to 357, so immediately you get these triplets. Okay. So, 3 4 5 5 12 13 7 4 and 25. So, if we rewrite this equation see in this particular form and then you substitute the value 2 4 6, it immediately gives you 3 more triplets. So, in this you can see that so these 2 triplets are one the same, but the other are different. Okay. The other example which has been given by Bodhayana, for instance 15 36 39, how did Bodhayana get that? See here the principle behind generating the rational triangles, this is another way of looking at it. So, here there is a Vedi which is called Saumika Vedi, and in the Saumika Vedi what should be the length, what should be the, it is not actually a rectangle, but it is slightly different kind of a thing. So, wherein it is a sort of trapezium kind of a thing. So, wherein so the length of the sides and so on are specified. In that context, so we find these sutras in Ashvala Apastamba, Trika Chatushkayoho Panchika Akshnaya Rajjuhu. See, Trika Chatushkayoho Akshnaya Rajjuhu, as I told you, is the hypotenuse. Trika Chatushkayoho, if the sides are 3 and the 4, then Akshnaya Rajjuhu is 5. Then it says Tabhihi Trirabhyastabhihi Amsau Chaturabhyastabhihi Shroni. See, in fact, so this can be sort of written like this. See, Trirabhyastabhihi. Abhyasta is sort of multiplication. Okay. So, you take 3 and then do this process. So, then you will get 12, 16 and 20. So, if you take 4 and then do this process, then you will get 15, 20 and 25. Then he says Dvadashika Panchikayoho, start with 5, 12 and Tabhihi Amsau Dvirabhyastabhihi, you take 2 and then do this process, then you will get 15, 36 and 39. So, this is the kind of triplet, see, as I was mentioning. So, this has been given by Bodhayana also. Anyway, so the principle that seems to have employed here in arriving at this triplet, one of the speculations is that they had used a general formula and then substituted, see for instance if you see 2, 3, 4, 5, 6, so you get all the triplets that are found and given by Bodhayana and later by other author, Apastamba also. You get various in triplets, and all these measures can be taken to be the measure of the various Vedis, so which they have used for various sacrifices. So, there is an interesting application of this Shulba theorem. I will discuss one application now. So, Nana Chaturashre Samasyan. Samasyan means desirous of putting together, which means you have two squares of different size and you want to create a square whose area will be the sum of these squares. Okay. So, Samasyan, so it is a geometrical construction. So, all that you need to do is, so closely follow this figure. So, A, B, C, D is one square and C, G, H, I is another square. So, these are the two squares and now you want to construct a square whose area is sum of these two squares. See, Nana Chaturashre Samasyan, desirous of doing, Kaniyasaha Karanya. See, Kaniyasaha means of the smaller one. So, Karani here refers to side, Kaniyasaha Karanya by the side of the smaller square. Okay. Varshiyasaha Vridham Ullikhet. So, Varshiyasa means the one which is larger in dimension. So, Varshiyaso Vridham Ullikhet, all that he says is you have to take the dimension CG and then mark it in the larger square which is same as BE. Okay. So, Varshiyaso Vridham Ullikhet. Then Vridhasya Akshnaya Rajjuhu, here the term Vridha refers to a rectangle. Okay. So, it is not Vridha, it is Vridhra. So, Vridhasya Akshnaya Rajjuhu, so the diagonal of this, see, Akshnaya Rajjuhu which is AE, Samasyatoho Parshvamani Bhavati, see, Parshvamani is side. So, Samasyatoho Parshvamani, so of the square which you want to construct as the sum of the area of these two squares, Parshvamani will give you the side. So, basically what you will get is AKHE, so this is the square. Okay. So, with this, so I will conclude my lecture today and we will have the next part of Vedas and Sulbasutras in the next lecture. Thank you. Yes, sir.
Using the stick, you told how to find out the east-west direction.
Correct, correct. Yeah.
Similarly, to find out the time,
Yeah.
There is a small sloga.
Yeah.
Could you tell me that you have shown only the trigonometrical calculations from the shadow, using the shadow.
Yeah.
To find out the time.
No. See, what I said was this formula is encoded in the form of a verse that we have decoded in the form of modern notation, and that is what it translates to, is what I said. This stick which is Shanku is a very effective device to determine so many things. So, in fact, there is a chapter called Triprashnadhikara in almost all the astronomical texts you will find, and the device which forms the basis of this chapter to conduct various experiments and determine various quantities of astronomical interest is the Shanku. They will place it and then so based on the shadow you will be able to determine the latitude of the place. In fact, Triprashna means three questions. So, Dik, Desha, Kala. So, Dik Jnanam, Desha Jnanam. By Desha Jnanam we mean you want to know where you are. So, where you are essentially is given by latitude and longitude, and in fact latitude is the most important thing. Latitude basically tells you how the time will fluctuate, see how much duration of daylight will be available for you to do the day to day transactions. So, the shlokas of course we can go back and then tell you, but it is not a simple shloka where this shloka basically gives the description of the terms in the formula. So, what is to be multiplied by what is to be divided by what.
My question is, but you know, by the same argument, then the shadow of the Roman should also fluctuate on a day-to-day basis.
No, it will not. See, I will tell you. So, naively it will sound to you that way, but the point is this variation in the rising point is due to change in declination of the sun. The ecliptic and equator are inclined, so by about 23 degrees. So, from the east point sun will move to 23 degrees towards the north, return back and then south. So, if you know the day on which it is going to be exactly So, in the east point and then it may, so this will happen on the equinoctial day. But suppose you have to do the construction on any given day, say at any given place. So, this will be the most reliable method. The point is, on a given day, so the path traced by the sun will be almost parallel to the equator. So, leaving out the very minor change in the declination. So, within a few hours in which you take the shadow measurement. So, the path will be, so this path is apparent path which is due to the rotation of the earth, and therefore, the path that is traced by the sun in the background, so will be more or less parallel to the equator, and therefore, when it does not matter how far it is moved from the equinoctial point, wherever be the rise, so there will be a corresponding shift in this side also. So, and therefore, the points that you will get by this will be, so the line that you get will be parallel to the east west line. So, by connecting these 2 points. So, but looking at that, so if you say this is the rising point, that rising point will be shifted from the equinoctial point, so depending upon the declination. If the declination happens to be 0, it will be exactly east point. So, that is the point.